Right, so what's this massive thing on my bench? It is a Harvard base station. So on box number 28, there's quite a few sets in box 28, so we'll be some time going through these. So those of you with repairs in will have been given the box number. Did I say box 18 or did I say 28? We're on box 18. Right. We will connect this up to the test equipment. We're going to run it on the power supply. This has come as a service set from somewhere, and we're not here to criticise other people's thing. First thing I've noticed is this plug is no longer legal in the UK, so that does need to go. I'll have a word with the customer and see if they want me to change it. I was an electrician in 1979, but that qualification hasn't been kept up. So although I can kind of pat test things, I'm not qualified to, am I? You know what I mean? So when we change plugs, we don't charge for the service because I'm not qualified. Was once, not now. We'll start taking screws out because there's a lot of them. Right, switch on. So we're putting on a power supply so we can control the voltage. So I know that the power supply has had some service work, but I just need to do it my way. So what is it, about the 5th today? No idea. 5th of March 2023, Harvard H407, and the serial number 01410. Good. It's on channel 21. Right, we'll get our standard replacement Cybernet mic and we'll do everything with there. So when we do deviation, sometimes it can differ because we're using a different mic. So make sure the RF gain and mic gain are there. Squelch is down. You can hear the signal generator. First thing we're going to do is check PA. So we're on DC on the changeover switch at the back, so it's not on AC. Right, see what happens when we switch PAM. Testing 1 2, testing 1 2, 1 2, 1 2, 1 2, 1 2. Good. So it works on the volume control on these sets. And we can tick the box off. The meter lamp's lit, we can tick the box off. That's all we can. So we'll plug our test equipment into the other socket so we can get a synod reading. Switch back to CB. Just check channel 9 works, it does. So we're on channel 20. Let's switch picture in picture on. Yes, there it is. And we'll key up. And we've got 3 watts. Bearing in mind our test set's a bit selective. Channel 40. Could say 3.1 watt. Channel 1. 3 watts. So that is fine. Low power isn't adjustable on these sets, but we'll switch it on and we'll see what it reads. At the moment it's 200 milliwatts. And the transmit current back to full power. 1.3 amps. Deviation 1212. Why haven't I got any? Because I'm on channel 1. Let's just check that current again. 1.38. Deviation. Wallow. Wallow. Just check we're actually tuned in right. Wallow. Wallow. I've got 3.5 there, so it's a bit high. And the frequency. Now, the other person who set this up says it's slightly low and it won't come up anymore. So it's showing on ours. I'll just put that on the screen. Just slightly high. That's fine. 27. You know, I could put 10 frequency counters in a row and they're all going to be so minutely out. But really, that's fine. I might just pop it down to 27. Right, let's look at sensitivity. And at the moment, the transmit is actually spot on, but it will need changing when we change the transmit power. So let's see what the receive's doing. Put the sine off meter through. Oh, this is a bit of all right. My goodness. It's 0.34. Naught 0.27, and if it will do 20, it's 1.2. Let's look at what they came up with on this. Yeah, slight difference, it really doesn't matter. So squelch, tight. Let's turn the squelch to full. I'll put the attenuator on here. So I'd like them to come in at 100 microvolts. There's no hard and fast rule on that. But what you don't want is a squelch that never ever opens on full. And conversely, you don't want one that's wishy-washy and you can't even squelch out the Wi-Fi from next door. We don't have a next door though. No, that's ridiculously high. It won't. We can't get that to open at all. Never opens. Right, we'll do the opposite. We'll go to threshold. Switch the signal generator to standby. Oh, that's very sensitive. Now the squelch does let these sets down. Don't get me wrong. Yes, 0.3 microvolts. So that is fine. I just would like it to back it off a bit. And the S meter should be S9 at that point. Well, it's S8 and 7/8. Again, you know, one machine, one test set, and another. So what is it? Just get a proper reading. Well, we've got 300 microvolts, but again, that's fine. The switches are all right. We've checked those. We've checked the potentiometers, and we've plugged things into every socket. So there we go. So that's filled in a bit of those. So we'll open it up. We'll start with the VC. So this person's bought this. This set's supposed to be serviced, and I'm quite satisfied this works properly. But of course, you can always do something, can't you? Like tuning out the church organs. We could go back and start again and finish it a second time and then 2 hours later, having done that, we could go back and tune it again, because it would never end. And I could come back to this tomorrow when I've done it, and it may be slightly different. So it's on frequency, it's doing a decent power output. Might end up having to change a ballast resistor, because these can be difficult to get 4 watts out with the little tiny 2 watt ballast resistor that's put in. I'd like to get this done today. It's Sunday and I'm between church services. So in the power supply they've changed that capacitor. We're going to change those two. It's got the hefty ballast resistor, and that's fair enough. It's because sometimes you've got a smaller one than that. We might have to change that value, but we'll look into that. If I can get 3.5 watts out of the set of my watts, then I'll be very satisfied. So we're going to start with the VCO. I'll need to get the service manual out, because can I remember what I did? No, of course I can't. It must be 10 days since I've seen one with this chassis. No idea where earth is, so we'll play it safe and pop it on a core. Right, so I need the Amstrad manual. Seeing as Harvard, when I wrote to them in 1982, said they didn't have any. At least that's something Amstrad always did, and that was have good manuals, and for a low cost. I mean, I paid $16.99 for each of the realistic manuals, and I would like to say that this was something like $3.50. Might have even only been $1.95. They were a good price. I tell you what, when I wrote to Rotel, they sent me it free. It's only one that did. So it's channel 1 that we do the VCO initial test on. So we're on channel 1. It's the far side of capacitor 22, which is there, and we are supposed to have 2 volts. We've got 2.1. That is absolutely fine, not touching that. And then in transmit, $2.12, absolutely fine. Swap to channel 40, should be, and you can take all this with a pinch of salt, because I don't know what meter they did this with. It's supposed to be between 4 and 5 volts, but that's ridiculous. We never get that, and the phone's ringing. Okay, so 17 minutes later. Now, this is what goes wrong. So I get phone, somebody wants me to transfer some money. Someone I know wants me to transfer them some money from their aunt who lives a mile from here. And this person lives 7.5 miles away, and he'd have to walk otherwise. So I can do that from time to time. I can do it today. But now it leaves me short to try and pay any of my bills. I'm not made of money, and I don't get much as a church organist, and I don't get very much at all out of this, as you can well imagine. So that's cost 17 minutes. That gives me 12 minutes left on this radio, and then I've got to go and do my church thing. So this is what happens. So I don't know whether we'd completed the VCO 3.6. I was saying take this with a pinch of salt, because it's not going to be 4 volts, and so don't worry that you can't get the 4 volts. That lower one's quite important. So what was it? See, I've now forgotten. $2.12. That's fine. We'll just deal with that frequency. That's interesting. Oh, so it's now just slightly low, which is what they said. So the set's either warmed up or it's affected by the lids being off. I'm sure they're quite right that that's right at the top, and I'm not going to break it. Yeah, 79123, that's fine. Take that off. So making sure we're on channel 20 and putting this meter away, which by the time I put a base station on here is now in the way, but I will want to check the power supply, but we'll run out of time by then. So on my 3 watt range, which you can't see because I've got the wrong camera on, so that I'm just at the end of my full scale deflection, so it's easier to just make sure it's right on that lower scale. Yeah, I mean they're both peaked. Just change scales now. And I can find the right trimming tool. Is it under the set? It is under the set. How naughty of it. That's fine. I won't redo that until we're satisfied with there. That's not hot enough. That's at peak. That's at peak. Well, I can see that we've got a coil there that's been fiddled with at some point. I'm just going to see whether it needs compressing. That still remains the same, but I prefer it to be compressed. No, we're going to have to change the ballast resistor, aren't we, to get to something a bit more how I want it. So we'll take the immaculate bottom off this immaculate radio. I don't know where people are digging 40-year-old radios up with this immaculate. Just look how clean the inside of that is and the outside. Unbelievable. Right, we'll take the power off and we'll unsolder that ballast resistor, and then we'll swap it for a little bit lower value. So if you come across these and they're being linked out, you must put something in, or you'll end up transmitting more on aircraft band than you will on CB band. That was a silly thing today. The B and B in CB stands for band, doesn't it? You know what I mean. There we go. Just clean those two up. I think they're 3.6 ohms these, 3.3 ohms. We need to drop that a little tiny bit, probably 2.8. That's what we got. I've got a bag with various 7-watt resistors in. Oh, I don't want to put that one in. That would be alright if there was one in it. And last time I ordered them, they were about a year coming, so that's another problem. So we've taken the sleeving off the existing one. If I can find the other end, that is. That wants a bit of solder on it, wherever it is. Good. So put the power supply back on. Now I've got 4.2 watts. I'll just check the procedure. Is it tuned down for setting the power? Where have I put the manual? They're kind of expecting put 3.7. Just 2, 3, 4, 4, 6 and 8 in accident there. So we just need to detune 8, and that's clearly going to go lower. The slightest touch and it's gone exactly the power we want, 4 watts. Good. Now part of that is that these are more up to the job. Deviation. Wallow. Needs to just come down a fraction. Wallow. That's it. Right. So it's 2.2 average to 2.5 as a peak. So that's done. So we know that's 4 watts. Let's just check the other channels. I'd like it to be somewhere near 4.1 and it's 3.9. Low power is now, go to channel 20. $270 milliwatts. And the transmit current is now 1.42. Good. So the first thing we're going to do on receive is go over to the oscilloscope and just check the detector, because it can go out on these sets. So I've got 100, I haven't, that's 100 millivolts. Start again. So I want 100 microvolts S9 equivalent, that's what I've got. But just make sure that's peak. Very slight adjustment, but I mean, you know, even mailing these things in the post can knock things like that slightly out. Very good receive. We'll go over to the sound meter. I'm not expecting to get anything else. Nothing there. Nothing there. Tiniest bit there. Biggest signal on for these IFs. That's all spot on. So now, see what where we are. So I've got 3.1. Oh, sorry, 0.31. So that detector's made a little bit of a difference. So for 12 dB, we've got 2.5, 0.25. And amazing, we've got 0.95. So we'll just make sure the S meter still says S9 in the correct position. Well, it will do in a moment. I can never remember which one's which. I think that's the S meter. Spot on S9 now. We never did the transmit meter, so I'll just do that. It wants to be in the centre of the red zone, and it's now, because the power output's a little bit higher. There we go. Centre of the red zone. And squelch. So I'm going to put squelch to full. Put 100 microvolts on the attenuator. So I want to adjust the squelch till it opens. And that should be it. So it's opening is 100 microvolts. Just the tiniest little adjustments. So it's now 100 microvolts. And the sensitivity at the sensitive end. Switch the signal generator to standby. Set the threshold. Switch the signal generator back on. Straight in. So just as before, it's 0.3 microvolts. There's me saying it lets them down on this chassis, but in fact, 100 microvolts. So we'll unplug the test speaker. Internal speaker works. So the idea is that if that's the one that came out is physically bigger, but it isn't as powerful. I think that these are 3 watts, and so the trouble is you're trying to get a 4-watt transmitter out of it, and these just get too hot and the resistance changes. So these is either 6 or 7 watts, and it makes all the difference. So the other thing I need to do, I'm going to have to put a pause on this now because I do have to go. But the other thing I'm going to do, I'll just take the power supply off. I'm just going to pop this power supply out. So that big capacitor's being changed, and that's fine. We're going to just check that these 2 have been changed as well, because whilst you're at it, you may as well. It's a bit of a swine to get to. It's just a matter of getting this subboard out. I don't want to not get in properly. Now we'll change the plug. We'll put a pat test. I'll just ask the customer whether he wants me to change the plug. You see 18-year-olds doing a half-day pat test course, can't you? And then they can sign these things off. But me, with 40 years of experience and having qualified at one time as an electrician, I can't sign them off because I'm no longer qualified. You see how bothered I look, can't you? So these capacitors which are coming out aren't going to be faulty, but they need changing at this stage. So I can't see they've been changed. We'll do that when we get back. Right, so we've done the capacitors there. You've got 10 microfarads at 16 volts. You've got 47 microfarads at 16 volts. I've replaced them with 25 volt. I'm just going to swap this plug. It's got the correct 3 amp fuse in it. But these plugs were 1950s, and you need to have shrouded pins these days, so it's just something. It's correctly wired, everything's tight, but it does need that changing. I think they're all of £1.69. The wires aren't quite dressed how I would. I mean, back then you didn't get plugs on appliances. When this was made, you were expected to be able to wire a plug, and we certainly were taught to do that at school, along with using a rotary dial telephone and so on. So we're going to plug, and then we'll pat test it, and then we'll plug it in and just make sure the power supply is set up. Radio's done. Bob's your uncle. I'll go through this with you. We've only got black plugs. I'm sure that most households would hate black plugs, but that's what we buy in. They're actually more expensive than white plugs. So we buy them with a 3 amp fuse, which is correct. And I find the quickest way to do this is to use the right screwdriver, which is actually not right here on this bench. So I take one of the cord grip screws out. I take the other out enough to swivel around the cord grip and then screw it somewhere into place. We're going to open up the 3 screws. And then I want to dress this cable correctly, because as it is, I don't feel it was. It needs a bit more pulling out, to be honest, from the rubber band. Not Citizens band, rubber band. So we're going to want the cable grip to be there. So we want the earth. I think the earth is the right length. It needs some slack in it. So that's the last to pull out if there was a snag. So we want the shortest one is best to be the live, the brown wire. I'll just use the side cutters. Best to twist the conductors. So this type of plug, you can use either a flat blade screwdriver or you can use a Phillips type like we have today on here, which is handy. So I'll put that back and then we'll just feel where that wants to be, about there. Twist it right round, lose the terminal in the works, I might as well put the cord grip back at that point. So the way the previous plug was on, you'll see, you'll remember that the wires were under some kind of strain. Sorry, as the plug was, there was a lot of slack and it was all looped up inside. Tighten back up the cord grip. So now I'll put that earth in. It's a bit tight to push out. So wouldn't need much of a pull for that to come out. They're all tight, of course, then followed by the neutral, and then finally there's quite a lot of slack in that earth. That's got to be the last one you're pulling out. So we'll put the top back on. And we'll see whether we've got a pat tester in here or whether we haven't. Okay, so hopefully we can see that is everything's right. Earth, insulation and so on. I hadn't got it switched on initially over to AC, so I'm satisfied that's there. But as I say, my certification as an electrician has long ended, and I haven't been on that half-day course with all the 19-year-olds to learn how to use a pat tester. So we don't offer that as a paid service. Right, now we'll plug this into our mains power supply, and so we are powered up. Make sure the power supply is off. Make sure we're not even plugged in. And we'll just see what voltage this power supply is doing. So we're set up on 13.8 volts. And let's see what it is now. So where's the power going? There, by the looks of it. So it's set at 13.76. I'm happy about that. I'll just see what the power's doing. And it says 4.1. Well, the set's cooled down, so that's fine. I think that's, is that 3,300? It is. Yeah, he's put the right part in there. I might have gone up a very slight amount on the voltage to 40, but he's put 35 in, and that is more. Back in the days of Bremmy power supplies, when CB wasn't legal in the UK, so prior to November 1981, there were some CB accessories coming in a little before, and we got these Bremmy power supplies intended for 220 volts at a time when the UK was 240 volts, and the capacitors in them were something like 28 volt rated, and on UK mains that voltage became something like 28.5, so they were popping within a month of being bought, so that was always a snag. So when you see figure of 8 cable rather than the proper 3-coil leads on some of the earlier Bremmy and other Italian imported power supplies, it's something to watch that the capacitors inside haven't died a death. So there we go. I think we can put the lid on this. It's a lovely radio. It's probably the best condition one I've seen for a very long time. So we'll put some of these million screws in the back. So now you can see you've got the AC/DC switch. Not going to be too tight on these because I need to put them all in first. Right, you really want to watch me screw all these screws in. I don't know how much of our form we've filled in on the clipboard, but I'm putting it together now, so I don't think we'll be able to fill much more of it in. So arguably these are possibly more sensitive than the Cybernet 134 chassis. This is the Cybernet 002 chassis, for those of you who don't know, also referred to as the economy chassis, because it's got less potential facilities than the 134, so it was cheaper to manufacture. You'll find that nearly every component, every active component in it is made by Sanyo. There we go. Lovely. Right, so we'll swap the aerial. Still hear the signal generator. Oh, what can we hear it down to before I unplug that? We've been doing that recently. So we're at 0.3 of a microvolt at the moment. So when you consider that swish looking Cobra we did was 1.4 microvolts when it came, one when it left. So it was there. And this is now, listen to this, 0.3, 0.25, 0.2, 0.15, 0.1, 0.09 I can receive down to. Good. Right, we'll plug the aerial in. We'll see what kind of good, bad, indifferent buddies are out there. Well, later on we'll get a on-the-air test with Mr. Chippy. Actually, that's quite dusty. That socket. Let's move it upwards so you can actually see something and switch picture in, picture off. One and a Roger. Foreign interference. Shouldn't be anything on these channels even from abroad because they are unique channels to the UK. So there you are. Right, lovely. We'll leave it at that. I don't know why I put it on 19. We'll put it on 20. We'll leave it at that. So I hope you found that interesting. That is the Harvard H407 base station using the Cybernet PTBM 002F chassis from 1981. Thanks for watching.